In step 1 of our demonstration of the tire pressure monitoring system, we're going to attempt to view the RAM locations at reset in the 68 HC11. I'm going to press reset while power is up, which should reset the RAM locations. Our locations we're going to look at through the Axide software at location 0200, which is where we're storing our data in RAM. I'm going to replace the jumper so that we can read the RAM and hit reset. If we notice at the 0200 location, we can see the bytes here that start with 18, 86, C3, D9, etc. in hex values. That concludes part 1. Step 2 in the process is to configure our RF transmitter and receiver. At first we need to plug in 9-volt power supply to our secondary board that allows power to be supplied to the RF transmitter continuously so we don't lose its memory. By utilizing its SPI connection serial port, we're going to download a script file that will configure our RF transmitter to receive the data that is coming from our tire pressure system inside the tire. I will load the script file. First I will connect, and we can see that our terminal is connected and we have data in our registers. Then I will load the script file that meets the specifications that we need in order to capture the data. Now we can see that this is loaded. Next thing I will do is turn on the communications. And we can see in our terminal down here that we are receiving the data across the connection that's coming from our tire module. This is the end of step 2. In step 3, we will continue on by showing that the data is being received by the receiver and passed through the HC11 through the SPI. We have connected inline logical converters that step up our voltage supply, which is 3.3 volts in the RF, into our HC11 of 5 volts. Data is now being received by the receiver, and we have written a program that will monitor the SPI flag and blink a green LED every time it receives bytes of data, and will blink a red LED every time it receives a full 13 bytes of data. We have built in a timeout that if it does not receive the full 13 bytes, it trashes the data and goes back to receive another full 13 bytes. We'll turn the lights off so that you can see the lights blinking a little better. As we can see now, the green LED is blinking faintly, and there we received a full 13 bytes because the red LED has shined. That is the conclusion of step 3. To conclude our demonstration in step 4, we are going to go back and use Axide to read the RAM that has been rewritten since reset. We will read the same memory locations of 0200, which is where we have stored our 13 bytes of data. I'll replace the jumpers so that we can read the data per reset of the HC11. As we can see in 0200, 13 bytes now start with 03, 00, 61, E4, etc., which is different than the data bytes that are stored in this memory location as of reset. This proves that our demonstration that we've transferred bytes of data from the tire through the MCU, RF to the RF transmitter, then through SPI, through our logic converter, and into RAM of our HC11. That concludes our demonstration.